Let's look at episode 27 of Prime Puzzles. Five friends, A, B, C, D, E, decided to collude in an online exam to get more marks than the rest of the class. Prior to the outcome of the test, they decided to rank themselves from 1 to 5, with 1 being the rank of the highest scorer and 5 being the rank of the lowest scorer. They also decided that no two people would get the same marks. Knowing each other's strengths, weaknesses, and extent of collusion, we observed the following about the performances of the 5 of them only. Okay. Then we have conditions. If A got the highest marks, then B would get the fourth rank, while D would not have scored the least marks. If B did not get the second or third rank, then C would have scored the least marks. Basically, we have 6 conditions, and all of them start with if. Additionally, the first question, if R count X is the number of different ranks that a student could have received, then which of the following is the highest? We have 4 options here. Then we have if A got the fourth rank. Another question with if. Then the numerical sum of ranks secured by B and C is. Can you see question 1 and question 2 basically tells you there are going to be multiple cases. So our challenge in this question is going to be to identify how do you get to those multiple cases when all you have are conditional statements. But at least we know for certain there are going to be multiple cases. In fact, in that vein, question 3 is especially useful. What is the total number of different rank combinations that 5 of them could have secured? This is having options 8, 6, 5, and 7. So as of now, I know for certain maximum number of cases that are possible are 8. Beyond 8, there will not be any more cases. Let's go ahead and try to record this information. The smart thing to do here is, if you keep going back to these individual sentences, it is too language heavy. So try to capture that information, in symbolic form, and that will make your work easier. Looking at the first condition, how I'm capturing that information is if A got the highest marks, if A got rank 1, then B would get the fourth rank, while D would not have scored the least ranks. Okay, D would not get rank 5. This is condition 1. Condition 2 is if B did not get the second or the third rank. If B did not get the second or the third rank, then C would have scored the least marks. C would have scored 5 marks. A good insight here from condition 2 is, can you see that B can now potentially get rank 1 or 2 or 3 or 4. B cannot get rank 5, because if B gets rank 5, condition 2, if part of condition 2 is fulfilled, and then B is also getting rank 5 and C is also getting rank 5, 2 people cannot get the same rank, because they had also decided that no 2 people would get the same marks. If you're not getting same marks, you can of course not get the same rank. So for B, we have now narrowed it down to only 4 possible ranks that B can get: 1, 2, 3, or 4. Let's go to the third condition. The third condition was if D got the second rank, if D is equal to 2, then A or B would not be equal to 4. Neither of them can be 4 then. Okay. Condition 4. If C got the third rank, then D would get the second rank, while E would not have been the highest scorer. E cannot be 1. Okay. Fifth condition. If E did not score the least marks, E is not 5, then A would get the third rank, while B would not get the second rank. Okay. From condition 5, we have extra information. If E got, can you see now, if E, the different ranks that it can get are 1, 2, and 4, and 5. E cannot possibly get 3 rank, because if E gets rank 3, then the if part of condition 5 is fulfilled, then A cannot be rank 3. So E getting rank 3 is an impossible case. This is also uniquely identified. Last condition that was present, if C was the highest scorer, okay, C is equal to 1, then neither A nor D would get the 4th rank. A or D cannot be equal to 4. I have basically captured all the conditions within this form, if then statements. Now, a good point to start here would be either with possible ranks of B or with possible ranks of E, because we know that their ranks are going to be fewer in cases. So I'm checking if B was rank 1. If B was rank 1, can you see the if part of condition 2 is applicable? The if part of condition 2 is applicable. So C should be rank 5. C should be rank 5. And carrying on from that, if C is rank 5, can you see condition 5 is now fulfilled? E is not rank 5. If E is not rank 5, then A has to be rank 3 and B does not have to be rank 2. Yes, it is not rank 2. Now we are only left with distributing rank 4 and 2 to D and E. Let's see, if I give 2 to D and 4 to E, would this be okay? I will go through all the 6 conditions and see if anything is getting violated. If A is equal to 1, not applicable. If B is not equal to 2, not equal to 2 or 3, applicable, and the condition is fulfilled, C is getting 5. If D is equal to 2, condition is applicable. A or B should not be 4. Neither of A or B are 4. That is fine. Condition is fulfilled. If C is equal to 3, condition is not applicable because C is 5. If E is not equal to 5, condition is applicable. A should be equal to 3. Yes. B should not be equal to 2. Yes. If C is equal to 1, condition is not applicable, which would mean this is an acceptable case. But hopefully you remember, putting 2 and 4 here was part of a case. The other case would be when I have 3, 1, 5 and 4 and 2 here. Let's see if all the 6 conditions are met. A equal to 1, not applicable. B not equal to 2 or 3, applicable. C is equal to 5, yes. If D is equal to 2, not applicable. If C is equal to 3, not applicable. If E is not equal to 5, A is equal to 3, B is not equal to 2, applicable and fulfilled. C is equal to 1, not applicable. This is also an acceptable condition. And now we have counted all cases where B was equal to 1. Now let's go ahead and put down B equal to 2. Now let me check with B equal to 2. If B was 2, then condition 2 is no longer applicable. Condition 2 is no longer applicable. But look at condition 5. Condition 5 is interesting. If E is not 5, then B cannot be 2. If E is not 5, B cannot be 2. So if I give any rank to E apart from 5, let's say I give him rank 1. If I give him rank 1, then B cannot be 2. If I give him rank 3, then B cannot be 2. If I give him rank 4, then B cannot be 2. If I give him rank 5, only in that condition can B be 2. This is uniquely identified. E has to be 5. Only when E is 5 can B take up the rank 2. Okay. Next thing. Now I have to distribute rank 1 somewhere. I have to distribute ranks 1 somewhere. If I give rank 1 to A, look at condition 1. If I give rank 1 to A, B should be equal to 4, and that would be a violation. I cannot give rank 1 to A. If I give rank 1 to C, what would happen? Now either this will be 3 or 4, or this will be 4 or 3. Can you see this condition here? Condition 6 would be violated. If C is equal to 1, A or D, neither of them should be equal to 4, but one of them here will definitely be equal to 4. So giving 1 to C, rank 1 to C is also not acceptable. So the only possible rank 1 that you can give is to rank D or is to D. We've given rank 1 here. Okay. Now we are left with either 3 or 4, 4 or 3. Let's see. Can I give 3 to C and 4 to A? Can I give 3 to C and 4 to A? Condition 4. If C is equal to 3, D should be equal to 2. If C is equal to 3, D should be equal to 2, but D is not equal to 2. So I cannot give 3 to C. The only acceptable case that we would reach here, if C is equal to 4 and A is equal to 3, Let us go through all the 6 conditions again to see if this is an acceptable case. A is equal to 1, condition not applicable. B is not equal to 2 or 3, condition not applicable. D is equal to 2, condition not applicable. C is equal to 3, condition not applicable. E is not equal to 5, condition not applicable. C is equal to 1, condition not applicable. So none of the conditions are applicable. So this is an acceptable case. Okay. Next case. Remember, our main stem of thought was different ranks that B can get. We've given B rank 1. We've given B rank 2. Now let's give B rank 3. Let's see if we give it rank 3, what would happen? If I give B rank 3, go to condition 5 all over again. If B is 3, A cannot be 3. If B is 3, A cannot be 3. Now A can only, as in, if A is not 3, can I say E has to be 5 now? Otherwise, if I give rank 1 here, A would have to be 3. That is not possible. If I give rank 2 here, A would have to be 3. That is not possible. If I give rank 4 here, A would have to be 3. That is not possible. Which means the only rank that E can take, is rank 5. Okay. Again, we'll get into distributing rank 1. Can A take rank 1? No, because then B would have to be 4. Can C take rank 1? If I give C rank 1, either A or D will be rank 4, which is a violation of condition 6. So C also cannot get rank 1. So the only person who can get rank 1 is D. D is getting rank 1. We're left with 2 or 4. Okay. A and C, 2 and 4. So let me see, if I give 2 here, I give 4 here. Is this a violation of any sort? A is equal to 1, condition not applicable. B is not equal to 2 or 3, condition not applicable. D is equal to 2, condition not applicable. C is equal to 3, condition not applicable. E is not equal to 5, condition not applicable. C is equal to 1, condition not applicable. So this is also an acceptable case. But hopefully you remember 3, 1, 5. This 2, 4 that I have distributed to A and C was a case that we were checking. The other case that we have to check is 2 and 4 here. Let's check this entire distribution. A is equal to 1, not applicable. B is not equal to 2 and 3, not applicable. D is equal to 2, not applicable. C is equal to 3, not applicable. E is not equal to 5, not applicable. C is equal to 1, not applicable. This is also an acceptable case now. So all cases where B is equal to 3 are recorded. Now the only case left for me to check is B being equal to 4. If B is equal to 4, can you see condition 2 is now in force? Condition 2 will now be applicable, which would mean C would have to be rank 5. And if C is rank 5, condition 5 is automatically fulfilled. So E is not 5, so A has to be 3. So if A is 3, now we are left with distributing 2 or 4 between these two spots. So let me put 2 here, 4 here. Let's see if this works. This condition will get violated. Third condition, if D is equal to 2, A or B will not be equal to 4, but B is equal to 4, which means I cannot give 2 to D. The only case left for me to check is, sorry, I gave 2 and 4, no, which was wrong. I should have given 2 and 1. 2 and 1 I cannot give. Let me give 1 and 2 then. Let me give 1 and 2. A is equal to 1, not applicable. B is not equal to 2 and 3, so C should be 5. Yes, fulfilled. D is equal to 2, not applicable. C is equal to 3, not applicable. E is not equal to 5, applicable, but fulfilled. A is equal to 3 and B is not equal to 2. If C is equal to 1, not applicable. This is also an acceptable case. And this is the end of all the possible cases. There are 6 different cases that are possible, and you can reach them if you slowly count through. You could potentially have counted it by taking E as the center stage of your storyline as well, because it has fewer number of cases. That would also be okay. But slowly count through cases, you will get everything. Let's look at the individual questions. If R count X is the number of different ranks that student X could have received, which of the following is the highest? R count A is either 3 or 2 or 4. He can get 3 different ranks. R count B, 1 or 2 or 3 or 4. So 4 different ranks. R count C, 5 or 4 or 2, 3 different ranks. R count D, 1 or 4 or 2. So 3 different ranks. So the answer to the question has to be option B. B can assume the maximum number of different ranks. If A got the 4th rank, then the numerical sum of the ranks secured by B and C is, if A got the 4th rank. So this case is being talked of. Numerical sum of ranks obtained by B and C would be 3 plus 2, 5. So answer to the second question is going to be option C, 5. Question 3. What is the total number of different rank combinations that the 5 of them could have secured? We had listed it out. We have got 6 different cases. So answer to the third question is option B, 6. Which of the following ranks did D not receive? D received 1, 2, and 4. So he definitely did not receive rank 3. Fifth question. What is the probability of A getting the 3rd rank as a percentage rounded to the nearest integer? A has got 3 in 4 out of 6 cases. 4 out of 6 is 66.66%. If it is rounded to the nearest integer, answer should be A, 67%. And the last question, if D got the 1st rank, okay, so all 4 cases are being talked of. If D got the 1st rank, what is the probability of B getting the 3rd rank as a percentage rounded to the nearest integer? When D is getting 1st rank, what is the probability B getting the 3rd rank? These are the 2 favorable cases. These are the 4 total cases. So 2 by 4 is 50%. Answer to the 6th question will be option C, 50%. This is the entirety of set 1. Hopefully that recording and slow processing of data was something you took away from. Okay, let's look at set 2 now. T, Q, R, S, T, U, V, W are 8 cities in a province, and all of them are on a straight road. Distances between 2 cities contained in the row and column are provided in the table below. For instance, distance between Q and T is 11 kilometers. So Q and T is 11 kilometers, while the distance between P and U is 5 kilometers. P and U is 5 kilometers. Okay. The distance between any 2 of these cities is less than 70 kilometers. This is the most critical piece of information. This is the most critical piece of information, and this is where our entire storyline, this is what opens up this entire case. Okay. Now, from the numbers given in the table, it is always advisable when you have certain data points given to you, it is always advisable to look at extreme data points, either the smallest distance available between 2 cities or the largest distance available between 2 cities. So I'm looking at the smallest distance is 2 and the largest distance is 52. Okay. So I'm going R and W, the largest distance. I'm going let R be 0. So W, I don't know if W is the furthest away or not. So W would be at 52. These 2 points we uniquely identify. The next thing we can identify is, let's look at T, Tikul. We have a number for this. We have a number for this. Let's look at Tikul, 46. Now from R, Tikul can be 46 on the right or 46 on the left. But if I take Tikul 46 on the left, it will be more than 70 kilometers away from W. And we had a condition, distance between any 2 cities is less than 70, which means I cannot take Tikul on the left. Tikul has to necessarily be on the right. So Tikul would be somewhere here, 46, 0 to 46, 0 to 52. These 2 we have uniquely identified. Wonderful. So Tikul also we know. Now let's look at Varenes. If I'm looking at Varenes, V, it can be 22 on the right or 22 on the left. But if it is not 22 on the left, it will be 74 kilometers away from W. If V is 22 on the left of R, it will be 74 kilometers away from W, which is impossible, which means Varenes has to be, V has to be 22 to the right, 22 to the right. We also know location of Varenes. Okay. Now, once for U, I can't be certain. It can be to the right of R, it can be to the left of R. Because even if I take it on the left, it will not be more than 70 kilometers away from W. So right now, U we will hold off on. Locations we know are R, T, V, and W. Now let's look at among the remaining numbers, what is the largest one? Among the remaining numbers, the largest one is 47, but I neither know about Santo, I neither know about U. So the number after this is 40. Okay, let's look at this 40. Can this 40, this 40 can be to the right of W, can be to the left of W. But if I take it to the right of W, it will be more than 70 kilometers away from R. If I take P 40 kilometers to the right of W, it will be more than 70 kilometers away from R, and that is impossible. So P has to be 40 kilometers to the left of W. So P has to be at the 12-kilometer mark. P is also identified. And now, can you see, checking wise, you can immediately do. See, P and T, we did not really check, but 12 and 46, yes, 34 is working out. P and V, we did not check, but 10, yes, it is working out. These distances are working out well. Okay. Now, fun thing. Now look at UA, X, A, T, UN. From P, it is 5 kilometers away, and from R, it is 7 kilometers away. From P, it is 5 kilometers away, and from R, it is 7 kilometers away. And the distance between R and P is 12, which is 5 plus 7 itself. Hopefully, this will help you realize that U has to be between them. 5 kilometers. We've got our U also. This is also satisfied. Okay. Now from among the remaining numbers, the largest number left is 47. Now Santo S can be 47 to the left of you or 47 to the right of you. If it is, sorry, 5. This 5 is wrong. This should be 7. This 5 is wrong. This should be 7. It is 5 from P and 7 from you. Okay. Now this 47 S, which is 47 away from you, it can be to the left or it can be to the right. But if I take S 47 to the left, it will be more than 70 kilometers away from W. So that is impossible. It has to be to the right. So S has to be 47 to the right, or it will be at the 54 mark. It will be at the 54 mark. Once I've got it at the 54 mark, let's go ahead and check. Are T and S 8 kilometers away? 46, 54. Yes. Are V and S 32 kilometers away? 22 and 54. Yes. Are W and S 2 kilometers away? Yes. Life is chill. Every number, everything has been uniquely identified. Let us now check the largest remaining number, 28. Okay, let's look at 28 between Q and U. It can be 28 to the left, it can be 28 to the right. But if I take it 28 to the left, can you see it will be more than 70 kilometers away from S? It will be more than 70 kilometers away from S. So 20 to the left is not possible. 28 to the left is not possible. It has to be 28 to the right. 7 plus 28. Q will be at the 35 mark. This 28 we have satisfied. Let's see if Q and T are 11 away. 35 and 46. Yes. Let's see Q and V are 13 away. Q and V are 22 and 35. 13 away. If Q and W are 17 away. 35 and 52. Yes. All distances, all locations, everything is uniquely identified. Let's get to individual questions. What are the two cities in the two extremes of the province? R and S. So answer has to be option B. What is the distance between T and U? T is at 46. U is at 7. So 46 minus 7. Answer to the second question will be 39. What is the difference between P and S? P is at 12. S is at 54. The distance between them is 42. Which cities are adjacent to T? Cities adjacent to T are Q and W. So answer has to be option A. A fairly straightforward set. All it required you to do was focus on the extreme data points. Once you do that, everything else will flow smoothly. That will be all for this episode. Hopefully you learned something. Okay, bye.